right. And we're going to look at our first lesson in Unit 4. This is going to start with Lesson 2, and this is on page 148 in your workbook. All right, now this unit is going to focus on types of angles again, but the Unit 3 focused on what happened when we had two lines intersect. All right, now Unit 4 is going to focus on what happens when we have a transversal, which is a line that intersects two or more coplanar lines. All right, and what type of angles are formed and what type of relationships exist, all right, between those lines and angles in the plane. All right, so now what I'd like you to do is the opener right here, all right, and you may or may not be able to figure all this out, and that's okay. Hopefully it'll become clear to you after you kind of think through this and we go through the lesson, but suppose you're given parallel lines M and P, as well as line T, which intersects lines M and P. So draw this diagram and label the angles 1 through 8. What is the least number of angle measures you need to be given in order to figure out the rest of the 8 measures? Explain your reasoning. So I'll give you a moment to do that. Pause the video, turn it back on, and we'll discuss this. All right, so here's what we have, right? So we have these parallel lines, right? So here's our two parallel lines, all right? And then we have line T, which intersects those. So here's line M, here's line P, and there's T, and that's the transversal there, right? And a lot of times that is labeled T to stand for transversal, which means it intersects these two lines here. And now the parallel symbol for lines, all right, we put like little arrow marks on there, so it could be like one arrow mark, it could be like two arrow marks, all right? And that signifies that M and P are parallel, or maybe you might see this notation, all right, which means that M is parallel to P, all right? And so I'm just going to label, all right, these 8 angles. Okay, now, so basically Unit 3 was this problem, right? Okay, two lines intersect, we get those 1, 2, 3, 4, right? And we looked at those types of relationships. So now Unit 4 is going to be, okay, so what happens when we now have this line and intersects two different lines? All right, so now the opener was this. What would you need to know? All right, and you might be looking at this and see that there looks like there's some connections between the angles up here and the angles down here. All right, and hopefully what you said or you figured out is what is the least number of angle measures you need to be given in order to figure out all the other angles? And the answer is 2. All right, I need a connection between this cluster of angles here on M and T and this cluster of angles with P and T. So for example, let's just say that I knew that angle 2 was 50 degrees and angle 5 was 50 degrees. And notice, if we know that piece of information, we can use everything from Unit 3 to figure out everything else, all right, in this picture, because we know 2 and 4 are vertical, so those have to be 50 degrees, right? We know 5 and 8 are vertical, so that means 8 has to be 50 degrees. And we know 1 and 2 are supplementary because they're a linear pair, so we know this is 130, which means this is 130. And then once again, we come down here, and this is 130, and this is 130. Okay, so now, if we have one pair of angles that connects, right, M and P here, from those two clusters of angles, we can figure out everything. Now, the catch is, and you're going to learn this, that these lines will have to be parallel, all right, and we're going to get to that in a little bit. All right, now let's look at some vocabulary. Now, I'm going to skip transversal, interior, and exterior, because we're going to actually define those on the next page, but I'm going to go to parallel here. All right, we've already talked about parallel in the coordinate plane, right, and we said that was two lines with the same slope, all right, and different y-intercepts. Now, when we talk about this, notice, and I should go back so you guys can see the picture here. When we talk about this, we're not dealing with slopes, all right? We don't have that information. We don't have equations of lines. So when we talk about things, all right, without equations, parallel means we have, all right, two lines that do not intersect in the same plane. And I should have probably used the word coplanar up here, two coplanar lines that do not intersect, all right? So it's very, very important that when we talk about parallel lines, they do not intersect and they are in the same plane, all right? So if we go back to the definition of skew, we said those would be two lines that do not intersect, but they're in different planes. So it's very, very important that when we talk parallel that we understand they're in the same plane. All right, so let's go ahead and flip to page 149 here, and we're going to define all these other terms on this page. All right, okay, so a transversal. So trans means across. So transatlantic flight, right, means you cross the Atlantic Ocean, right? okay, transportation, right? All right, so that means to get across. All right, so a transversal is a line that intersects two or more, and I'm going to use this word here, coplanar lines in different points. All right. And in different points is important because what this is trying to get away from is that we don't want them all intersecting here at this one point right here. All right. So we want them to intersect at different points. All right. So like you can see our diagram right here. So this would be our transversal. All right, right here. All right. So that's why we want two or more coplanar lines in different points. So we don't get this kind of spur of points right here around that one point of intersection. Okay. All right, so now what we're going to do is if you don't have it handy right now, go ahead and pause the video, but get a color pencil, a highlighter, all right, and we're going to use this to identify our transversal. And the reason is because when we talk about the types of angles formed here, all right, it's very important that you know what the transversal is because it's about perspective from that transversal, and you'll see that as we define things. So if I look at this, all right, first picture here, this right here would be my transversal. All right, it's the line that intersects, all right, two or more lines. And then if I number my angles here, 1, 2, 3, 4, 5, 6, 7, 8. The first type of angle we're going to talk about is corresponding angles. All right, so corresponding angles. Now, when two things correspond, they are in agreement. All right, so what we think about with corresponding angles, what we're saying is that they are in the same position. Their position agrees as we travel the transversal. All right, and so if I label this M and this P, and I get to T here, notice as I travel down our transversal here and I intersect at M, notice 1 is in the upper left. And then if I travel some more, I intersect P, and notice 5 is also in the upper left. The position of those two angles correspond. So those would be corresponding angles. So angle 1 corresponds to angle 5. Same thing, if I'm traveled through this intersection, notice 2 is in the upper right. When I get to this intersection, all right, 6 is in the upper right. So angles 2 and angle 6 are corresponding. All right, and then the same for 3 and 7, and then angles 4 and 8. All right, so when we say corresponding angles, that means as I go from intersection to intersection along my transversal, they're in the same relative position, all right, traveling down that transversal. And once again, it's important because specifically to the transversal we're traveling. And we're going to get into pictures where we have more than one transversal. All right, so it's very important that you identify which transversal you're discussing in order to identify your angles. Okay, now, all right, so now let's look at our next picture here. All right, so once again, I'm going to just identify my transversal here with my green highlighter. And then once again, I'm just going to add those numbers so we can talk about them. All right, so 1, 2, I'm going to try to label everything the same way here. All right, so we have our, same numbering system. All right, so now when we talk about interior, exterior, all right, and we talk about alternate and same side, all right? So this is going to help us identify the rest of the angle relationships here, all right? So everything else, like you can see here, is named according to their location. So when we say interior, that means they're inside of the two lines we intersect. So notice when I travel down, all right, so here's M, here's P, and here's T, here's M and P. And so notice 2, 4, 5, and 7 are interior. All right, so they're inside of these lines, right? So that would be angle 2, angle 5, angle 4, and angle 7. Those are interior. They're on the inside of the lines, all right, as we intersect them. Now, when we talk about exterior angles, those are on the outside of the two lines that you intersect. And so notice that would be angle 1, angle 3, angle 6, and angle 8. Okay? So interior, inside of the two lines you intersect, exterior on the outside of those lines. Okay, so now, then we add another term here, alternate or same side of the transversal. Okay, so when we say alternate, when things alternate, they're on opposite sides. Okay, same side means they're on the same side of the transversal. So when I look at this, so for example, all right, 1 and 6 are on the same side. 2 and 5 are on the same side. Okay, they're on the same side of the transversal. Okay, whereas, all right, 2 and 7 are on alternate sides. Okay, they're on alternate sides. All right, 2 and 8 are on alternate sides. Okay, 4 and 7 are on the same side. Okay, so like I said, so angle 2 and angle 7, those would be alternate. All right, they're on alternate sides or opposite sides of the transversal, right? Okay, a pair of same side would be like angle 3 and angle 8, right? They're on the same side, all right, of the transversal. All right, so they're either all above, all right, all below, or they're on opposite sides. Okay, now what we're going to do now is we're going to put this terminology together to create special relationships here, all right, for our angles. So notice what we're going to do now is I'm going to start with interior, okay, and alternate. So the first type of angles we would have are alternate interior angles. All right, and once again, what I'm going to do real quick is I'm just going to highlight my transversal in all 4 pictures here. And then I'm going to add our numbering system in here. So 1, 2, 3, 4, 5, 6, 7, 8. Do that in all 4 of our diagrams here. All right, if you need to pause the video to do that, please do. All right, same way if I'm talking too fast, you need time to write. Okay, so now notice alternate interior angles. Okay, so now the first thing is when we think about interior, we're now talking about just these angles right here, 2, 5, 4, and 7 from above, right? And now we want them to alternate. So they have to be on the inside and opposite sides of our transversal. So notice that would be angles 2 and 7. Would be one pair of alternate interior angles. And then 4 and 5 would be another pair of alternate interior angles. All right, so notice the verbiage is telling you how to identify those angles, right? So the interior, all right, tells you where they're at, and the alternate tells you, all right, the relationship. So notice now I could do same side interior angles. All right, same side interior angles. So notice we're still saying interior. So that means we're still talking about 2, 5, 4, and 7. All right, so 2, 5, 4, and 7. And so now notice the same side interior angles, all right, would be 2 and 5 this time. All right, and then angle 4 and 7 would be same side interior angles. All right, so once again, we're just kind of combining those two ideas. And then in a very similar manner here, we're going to talk about alternate exterior angles, right? Now, once again, exterior, that means we're talking about 1, 3, 6, and 8. All right, and then we want them to be alternate, so they have to be on opposite sides. So that would be 1 and 8, so angle 1 and angle 8. And then angle 3 would alternate and be an exterior angle with 6, so angle 3 and angle 6. And then finally, and you may have already guessed this, but you could have same side exterior angles, right? All right. So once again, since it's exterior, we're talking about 1, 3, 6, and 8. All right, and if they're on the same side, it's got to be 1 and 6, and then 3 and 8. And remember, for all these pairs, we have to have one angle from each intersection, right? Because otherwise, we're just talking about vertical angles and linear pair like we did in the last unit, right? So this is about what happens when we intersect 2 lines. So every pair, all right, no matter what kind you're talking about, corresponding, alternate, exterior, whatever it is, has to have one angle from the first intersection and a second angle from the next intersection. All right, so now what we're going to do is I'm just going to run through some examples on page 150 with you, all right, and just identifying those. Okay, now once again, it all is in reference to, all right, your transversal. So notice when we look at angle 1 and 5, all right, we want to identify what those are. So 1 and 5, here's 1, here's 5, and notice they're on this transversal. So C is our transversal, all right. And so when I look at this, angle 1 is in the upper left in this intersection. Angle 5 is in the upper left here. So these would be corresponding angles. Okay. And notice that's all in reference to this transversal. And notice now when I jump to 7 and 10, 7 and 10 are over here, correct? And now L is my transversal. That's what I'm moving down. And so I notice if I'm going down L, 7 and 10 are inside of the two lines I cross. They are on the same side, so 7 and 10 would be same side interior. All right. Now let's jump to 2 and 4. Well, when I look at 2 and 4, now this is a review, right? They're in the same cluster, right? And these would be vertical angles, right? So you can still use some of those angle relationships that we already know. All right, now let's jump to 13 and 11 here. Here's 13, here's 11. So now this, and I don't know, maybe this is supposed to be D here, got cut off here. But now this is our transversal, right? All right, and so when I look here, I can see that 13 and 11 are on the outside of the two lines we intersect, and they're on opposite sides of our transversal. So these would be alternate exterior angles, right? All right. Now, when I look at 14 and 12, okay, we're still on the same transversal here. The difference is now 14 and 12 are inside of the two lines we intersect, and they're on opposite sides of our transversal. So these would be alternate interior angles. All right, and then I want you to do the last two. Do 8 and 7 and 9 and 3. All right, and see what you do. So pause the video, do those two, and turn it back on. All right, so now 8 and 7 would be a review, correct? So 8 and 7, hopefully you said were a linear pair. And then now when we look at 9 and 3, so notice 9 and 3, all right, there is no transversal connecting 9 and 3, right? Okay, so that means that there's none. So this is just not a relationship. So you can just write NA. All right, so there's your introduction to types of angles when we have a transversal and two lines. Go ahead and finish the work on page 150 and 151 here, and I will see you guys next time.